A student investigated the dyes can contained in different colored inks using a chromatography. Water was a solvent. The diagram shows how the student set up the apparatus. As you can see, the chromatogram identified two errors in the way students set up the apparatus. What are the two errors? By looking at this apparatus, you can work out. So chromatogram is submerged in solvent or water. That is one thing. And the second one, the baseline is drawn in ink. Like he used the ink pen to draw this. So the first error, baseline is in the solvent. And the second one, that the baseline is drawn in ink. The second part, the student then carried out the chromatography correctly. The diagram shows the results. Which ink contains the greatest number of soluble dyes? The question is, which ink contains the greatest number of the soluble dyes? Number of the soluble dyes you can identify by number of the spots. So you can see 3 spots are there for black, 2 spots for purple, 1 is for blue, 2 for green, 1 is for yellow, and 2 for orange. So maximum is for the black one. Which two inks are made up of single soluble dye? So blue and yellow. From chromatogram, it is not possible to tell if the red ink contained different dyes. Suggest how this experiment could be changed to find out red ink contained different dyes. Basically, what happened, the red ink does not rise above the origin. So if ink does not rise above the origin, it means it is not water soluble. So we should alter the solvent, or we should change the solvent. Because when you alter or change the solvent, the red, use a solvent which can dissolve this red ink, you can identify what different dyes it consists of. Question 2. A student investigated the reaction between dilute hydrochloric acid and two different aqueous solution of sodium carbonate E and F. 3 experiments were done. Experiment 1, a burette was filled with 0.0 cm cube marked with HCl. Using a measuring cylinder, 25 cm cube of solution E was poured into a conical flask. 5 drops of thymol methylene indicator were added to conical flask. Dilute hydrochloric acid was slowly added from a burette to the conical flask while the flask is swelled until the solution just changes the color or color change. Use the burette reading to complete the table. Use the screen annotation to complete the burette reading, the initial and the final, and the volume of hydrochloric acid used. So initial burette reading is 0, and not only you will write 0, it should be 0.0, because a burette is accurate to 0.1, so you should use 0.0, not only writing 0. And then the difference will be 10.2. The next part, experiment 2. Experiment 2, conical flask was emptied and rinsed with distilled water. The burette was refilled with dilute hydrochloric acid. The experiment 1 was repeated using 5 drops of methyl orange indicator instead of thymol pathylene indicator. Use a burette diagram, complete the table. Use the screen annotation to complete the table. The final is 25.9, that's right, and the initial is 5.5, so the difference 20.4. So in the first experiment it was 10.2 and the second experiment it is 20.4. So if we have experiment 3, so basically what happened, the first experiment we added 25 cm cube of solution E and we add HCl from a burette, and we found that it required 10.2 cm cube of HCl for a complete reaction. If when we repeat the same procedure, the same experiment is repeated using 25 cm cube of E but different indicator, as you can see in the question, they mentioned experiment 2 was repeated, experiment 1 was repeated with 5 drops of methyl orange instead of thymol pathylene indicator. And how much we need for a complete reaction, the same substance, now we need 20.4, approximately the double volume. Why this leads to a different result? Because indicators are normally weak acids. So when we use the different indicator, the volume of the acid or volume of alkali required will also change. Even though the same solution E was here, we took same 25 cm cube of solution E, indicator was methyl orange here, the indicator which was used here was thymol pathylene. So thymol pathylene is stronger indicator, or it is also acidic. All indicators are weak acids but stronger acid compared to that of methyl orange. That's why this contribute to different volume of HCl required for the reaction. This was not the question, but I was explaining an idea that why there is a difference in the volume of HCl even though the same reagent is used in experiment 1 and experiment 2. But only different indicator, as different indicators are also weak acids. Experiment 3, conical flask was emptied and rinsed with distilled water. The burette was filled with dilute hydrochloric acid and 25 cm cube of solution F was poured into a conical flask. 5 drops of methyl orange was added into a conical flask. The dilute hydrochloric acid was slowly added from a burette while the flasks were swelled until the solution yet changed color, just changed color. Use the burette diagram to complete, so you can use the screen annotation to complete this part as well. The initial value is 2.4 and the final is 33, and the difference 30.6. So if a question is, look, when we were using solution E and methyl orange as an indicator, when 25 cm cube of solution E was used with methyl orange as an indicator and 25 cm cube of solution F is used when methyl orange used as an indicator, the amount of HCl required was 20.4 and here the amount of HCl required is 30.6. So which solution is more concentrated, E or F? Which solution is having a greater concentration? Unknown solution E or unknown solution F? So F is more concentrated, F is having a greater number of particles, that's why it needs greater amount of HCl to show a color change. E is having small number of particles, that's why it needs a small quantity of HCl to show a color change. So F is more concentrated or E is dilute. So what color change was observed in a conical flask in experiment 2? In experiment 2, first we were having an alkaline solution and then we add an acid. So methyl orange in alkaline solution, originally it is yellow in alkaline solution, then it will change to red or orange. Compare the volume of hydrochloric acid added in experiment 2 and experiment 3. So when we compare the value, means you have to take a ratio. In experiment 2 it was 20.4 and experiment 3 it was 30.6. So if I take a simplest ratio, I'll divide by a common factor, so simplest ratio will be 2:2. Or if I divide by the smallest value, 20.4 is the smallest value, so it will come out 1:1.5. And the reason, because solution F is more concentrated. 2:3, or when I take like in terms of 2:3 is same as 1:1.5 is same as 2:3 because I multiply by same factor. And the reason is F is more concentrated. Determine the simplest whole number ratio of volume of hydrochloric acid used in experiment 1 and experiment 2. So when you compare the ratio, experiment 1 we use 10.2 and experiment 2 we use 20.4. So when I take a simplest ratio, I'll divide by 10.2. So that will be 1:2. So ratio of experiment 1 is to experiment 2, that is 1:2. What volume of hydrochloric acid would required if experiment 3 was repeated using thymol methylene indicator instead of methyl orange? So how we can work out the experiment 3? You have to use a ratio. So when we first used, this was 10.3, 10.2. So this was 10.2. Now in the second experiment, in the third experiment, what is the volume? The volume is, when you take a ratio, as you can see here in this experiment, yeah, ratio is 1 is to 3, but when you check the substances, when we are comparing the concentration is when we compare the concentration, 1 is to 1.5. That is the ratio of the concentration. Like solution E and solution F, they have this concentration. So for a reaction, if 25 cm cube of E, if I need 10.2 cm cube of HCl, then how much HCl I need for F? It will be X, like 1.5 times. So cross multiply. So this will come out 15.3 cm cube. Is it clear? Because the ratio between E and F is 1 is to 1.5. So if I need 10.2 cm cube for reaction with E, I need 1.5 times more volume, and 1.5 times of 10.2 is 15.3 cm cube. So you have to show this, the ratio, and just state the value. Is it clear, this part? In part F, conical flask was rinsed with distilled water between each experiment. Why was the conical flask rinsed? Why we watch the conical flask? So mainly the purpose of the conical flask is to remove any residue which is left from the previous experiment. Why does it not matter if a little distilled water is left in the flask after it has been rinsed? Yeah, that's right, because distilled water will not alter or does not change the amount of ENF, or does not affect the pH of the solution. Or does not affect the amount of ENF. State two sources of error in experiments. For each error, suggest an improvement. The sources of errors in titration experiment. What might be a sources of errors in titration experiment? Normally for titration experiment, what we are using? We are using a measuring cylinder. So measuring cylinder is not accurate. We should use a pipette for, and yeah, pipette or a burette can be used. Then repetition is not there in this procedure. Student did not repeat. So student did not repeat the experiment, repeat and find the average. And what might be another error? like difficulty in identifying the end point. So we should add drop by drop or slowly. These are the sources of error, like difficulty. Look perpendicular and avoiding a parallax error is only in measurement of the volume. But in experimental technique, you cannot mention that. That is a personal error due to the observer, not due to the apparatus or technique. So difficulty or misjudging the color change. So how to avoid this error? Add drop by drop or slowly. And the second one, use of measuring cylinder. That is a source of error because so improvement is there. We can change with pipette for more accurate reading. Two solids G and H were analyzed. Solid G was copper to carbonate. Test on solid G. Complete the expected observation. Solid G was placed in a boiling tube. Excess of dilute sulfuric acid is added. Any gas produced was tested. Observation: it's a copper carbonate and we are adding an acid, sulfuric acid. So this will result in a formation of carbon dioxide, but you don't say carbon dioxide gas is released. You will mention observation is, we'll observe fizz, bubbles, effervescence, and a gas will turn lime water milky. Lime water turned milky, that's another thing. And because copper sulfate solution is formed, so we'll mention a blue solution is formed. Identify the gas produced in A. Which gas is released in A? That's carbon dioxide. Why does the solution turn blue? Because solution turn into copper sulfate. Copper sulfate is blue in color. As you add to carbonate, you add an acid and you add sulfuric acid. Acid plus carbonate gives salt, water and carbon dioxide. So salt will be copper sulfate, aqueous copper sulfate, then carbon dioxide, that's why bubbles, and water is there. So this copper sulfate is blue in color, solution blue, that's why resultant solution is blue. Aqueous ammonia was added slowly until an excess of solution produced in A. So when we add first, we'll observe blue precipitate, which dissolve in excess to form deep blue solution. Test on solid H. Another solid is there. Tests were done on the following observation were made. Flame test. So flame test, if it's give a yellow flame, it gives an idea that there's a sodium. Some of solid H is placed in a boiling. It was heated. Condensation appeared. So if condensation formed, what it gives an idea? It gives an idea this is a hydrated salt. Because hydrated salt or salts which contain water of crystallization on heating gives water droplet, or these condensation of water occur because the solid dissociate, give out that water molecule which condenses on the mouth of the boiling tube or test tube. Solid H was dissolved in a distilled water. The solution was divided into equal portions. About 1 cm cube of nitric acid followed by silver nitrate. This is a test for halide ion, chloride, bromide and iodide. And the solution remained colorless. It means there is no halide ion is present. Dilute nitric acid followed by barium nitrate. This is a test for sulfate ion. A positive result, white precipitate are due to formation of barium sulfate. So this confirm it is a sulfate ion is there. What conclusion you made about test 3? Test 3, it's not, there is no halide, not a halide. And what conclusion you made about solid H from result of test 1, 2 and 4? Test 1 state it is contains sodium. Test 2 indicate it is hydrated compound, and test 4 indicate it contains sulfate as well. So basically it is hydrated sodium sulfate. Planning of experiment. Cobalt, manganese and nickel are metals. They react with dilute hydrochloric acid to form hydrogen gas. Plan an investigation to find out order of these three metals. You are provided with a sample of each metal, dilute hydrochloric acid, common lab apparatus. Your plan must be your plan must make it clear how your investigation will be a fair test, and how would you use your result to place the metal in order of the reactivity. So basically hydrogen gas is given off. So whenever a gas is given off, we can measure the volume of a gas, and using a volume of a gas we can work out a volume of a gas in a unit time or given time. We can work out the rate of the reaction. So first we'll take equal mass of each metal and transfer by balance and transfer to conical flask. So we took equal mass of each metal and then we transferred that into a conical flask. Then use measuring cylinder. Take 10 cm cube of HCl, add to conical flask, place the bung and connect gas syringe. Start the timer when acid is added to flask. And record the volume of a gas in 3 minutes or 5 minutes. Then plot a graph. You can plot a graph between volume of gas and time. Then compare the slopes. The metal which graph shows steeper slope is more reactive metal. And for fair comparison, we should take equal volume of acid, we should take equal masses, we should take equal size of the metal, like the surface area should be same, equal temperature should be there, because these are the factors which affect the rate of the reaction. Is it clear, this experiment? So this was June 2020, paper 6, variant 1.